So 7.4 really is kind of cut and dry when it comes to talking about linear and nonlinear. So like we just talked about, linear is a line, nonlinear is not a line. So there's features about their equations and about how they look on a graph, all right, that will tell us whether they are linear and nonlinear. They cannot be both, right? It's either a line or it's not a line. Do you have any blanks in your notes? A linear function has a constant state of change. So you can find a slope. There is predictability between my x and my y values. A nonlinear function does not have that constant state of change. So there's no way for you to predict what the next point is going to be. You can't count rise over run to your next point and then rise over. You can't do that with nonlinear. All right, so there's no predictability there. Okay, so we're looking for patterns. We're looking for some kind of pattern between x and y. All right, so let's look at the first table. Okay, we have our x values and we have our y values. I want you to look at how x is changing. How do you go from 3 to 6, from 6 to 9, and from 9 to 12? Is there any kind of operation? It can be addition, can be subtraction, multiplication, division. Okay, how do you get from 3 to 6? You add 3. How do you get from 6 to 9? You add 3. How do you get from 9 to 12? You add 3. So there's constant predictability, meaning I could very easily predict. All right, would you place a bet on knowing what the next number would be? Okay. All right, so I would bet on that if I was a betting person. We don't do that though. Okay. All right, so my next number would be 15. I can follow a pattern. All right, so far so good. This is a linear function based on the pattern that I see. But now, and your y pattern can be different. It doesn't have to be to add 3, but I do have to find a consistent pattern. How do I get from 40 to 32? I can minus 8. 40 minus 8 is 32. So now you're going to test it on the next number. If 32 minus 8 is 24, then I can see a consistent pattern. What's 32 minus 24? Or 32 minus 8 is 24. Okay, so I subtracted 8 again. Well, does it work between 24 and 16? Does it work again? Are you just saying yes, or did you test it? Okay, did you do the math? So, yes, it works again. So, because of this, could you predict the next number? What is 16 minus 8? It's 8. So, because you can confidently predict the next number, it means that I do have a constant state of change. So, this is linear. Okay, you don't have to write an equation. You just have to prove the constant state of change between the values. All right, so now let's look at this next one. Let's look at the next table of values. I want you to try to find the connection between x and the connection between y. Go ahead and see if you can fill that in. All right, AJ, how are my x values increasing? Yes, it goes up by 2. Is that what you guys said? I'm adding 2 to each x value. Can you confidently predict the next x value after that? What would it be? It would be 9. Okay. Now, what's happening with my y values? Tristan? How do I get from 2 to 11? Okay. And then how did you get from 11 to 33? Yes, you added 22. Okay, and then did anybody do 33 to 88? What did you get? Added 55. Okay, so is there any constant pattern there? Is there any way to predict the next y value? No. So even though x increased by 2, okay, so here's our explanation. And actually, I probably should have added more to the first one as well. So we'll go back. So I'm going to say nonlinear. Here's your explain, and here's what you would write on a homework assignment. As x increased, or you could say increases, by 2, y increases by different amounts. So because it's different amounts, it's nonlinear. Okay, so the other one, the first one was linear because as x increased by how many? As x increased by 3, how much did y increase by, or decrease? Y decreased by how much? By 8. All right, so that's going to be your explanation, and you will have to give an explanation on your homework. All right? Good? Got it? Okay, so you try. Find your connection between x and find your connection between y. If there is a constant connection, then it's linear, but it has to be for both x and y. All right, so see if you can try this one. I don't mind if you guys work together. All right, to try to get to your answer. I'll give you guys about 2 or 3 minutes to work on this. All right. Okay, did you guys find a pattern with x? Did y'all find a pattern with x? Okay, what was your pattern with x? You're adding 2 to each value. Very good. What was your pattern with y? Okay, that you're adding 4. So negative 8 plus 4 is negative 4, plus 4 is 0, plus 4 is 4. Okay, so because there's a constant pattern, is it linear or nonlinear? It is linear. Okay, now can you explain it? As x increases by how much? 2. Increases by 2. Y increases by 4. Okay, so that's my reason. That's going to be my explain. All right, any questions? Not too bad? Linear and nonlinear? Okay, so now instead of having a table of values, you're going to have an equation. And there are certain rules for whether or not an equation can be linear or nonlinear. We know the equation y equals mx plus b. That's nothing new. That is the formula for a linear equation. So the equation has to be able to get into that format. All right? Which means I cannot have a square root. Do you see a square root in there anywhere? You see a square root symbol? Y'all know what a square root symbol is, right? It's this little thing looking. All right, that's a square root. Can't have a square root. Cannot have an exponent. Are there exponents in there? No, and there's no way for you to get rid of an exponent without taking the square root. So if you see exponents, it's nonlinear. Okay? Now, we're going to need to look at, I want to look at this one first. All right, y equals 4 over x. Because I've seen, all right, I'm going to give you the flip of that, the inverse. Y equals x over 4. One of these is a linear function. Equation, same thing. One of them is not. It all depends on where x is. So, does everybody agree you can put an understood 1 in front of these x's? You guys agree on that? Okay. So, the second one, I could write this as y equals 1/4 x. Isn't that rise over run? Yeah. I cannot do y equals 4 over 1 because then this is 1 over x. I cannot have x in the denominator. You say, well, I could just get rid of it. I could multiply this by x and then multiply this by x over here. Okay, but now you don't have y by itself. So all that being said, if x is in the denominator, and you can make a note of this somewhere if you want. If x is in the denominator, it's non-linear. There's no way that you can get it out of the fraction, and it has to be out of the fraction to be in slope-intercept. So if x is in your denominator, it's nonlinear. If x can be in the numerator, like we see in the second one that we just made up, then yes, it's linear. All right, so it's all about how it can be written. So go to the first one, go to the top left. Y equals 4 times x minus 1. Right now, it's not in slope-intercept form, okay? But could you get it in slope-intercept form? Could you do the distributive property? All right, go ahead and do that. Go ahead and do the distributive property. You guys know how to do this part. Go ahead and put it in slope-intercept, distributive. All right, Gabe, what'd you get? Y equals 4x minus 4. Is that in mx plus b? Absolutely. So this is linear. This is definitely linear. Here's what you can't do on your homework or a quiz or a test. You can't just say linear without any kind of proof. Your proof is that you wrote the equation. Okay? Well, look at the next one down. Y equals x plus 5. What do you guys think? I want you to write your answer right now on your paper. What do you think? Do you think that's linear or non-linear? Write it on your paper. I want everybody to have an answer written down. What do you guys think? Sam, what do you think?
I put non-linear.
You put non-linear? Okay. Is it written in slope-intercept form? Yeah, so it's linear. Okay. So if it's in slope-intercept, does that make sense? Okay. If it's in slope-intercept, so I'm going to say linear because, you can do BC for because, it's in slope-intercept. All right. That's the whole kicker. That's exactly what tells me whether or not it's linear. All right. What do you guys notice about the last problem? Has an exponent. So you say, well, I don't want an exponent because I need to get a slope-intercept. Well, the only way to get rid of it is to take the square root, which is also not in slope-intercept. So there's no way, if there's an exponent, there's no way to make this linear. All right, so I'm going to say nonlinear. And I'm going to do BC again because of the exponent. The exponent is what makes it non-linear. So we're not going to graph non-linear functions this year. You're going to do it next year. All right? The only thing you need to learn with pre-algebra is there are two. We focus in pre-algebra on linear equations and building a foundation for linear equations. You guys know y equals mx plus b. Okay? Then in Algebra 1, they're going to teach you nonlinear. All right? Good? Okay, so now, to me, I don't know why this is example 3, because it's the easiest of all. Is it a straight line or not? Okay? Remember, a straight line has a constant rate of change, even if it's 0. So number 1, what do you think? Nonlinear. You can just abbreviate it NL, nonlinear. Number 2, what do you think? Linear. You can just write L. What do you think about number 3? It is non-linear. You say, well, it was a straight line, yes, but then it kind of cracked in the middle and went down the other way. So it's not a continuous straight line, non-linear. All right, what about number 4? It is definitely linear, and it's also a proportionate relationship because it passes through 0. All right, any questions on the graphs? I bet you're hoping that that's on your homework. Okay, not too bad. Okay, so now we have light waves. Did you know that that's how we perceive light? Different light waves and how your eyes... It's really incredible. You're going to take anatomy and physiology at some point in your high school career. I don't know, personally, and this is just my personal opinion, I don't know how somebody goes through that class and then doesn't believe that there's some kind of an intelligent creator. The way our bodies, and the way our eyes especially, and our brains process information and process light waves, that's how you see different colors. Because it's different wavelengths of light rays. Okay, so the frequency in terahertz of a light wave is a function of its wavelength in nanometers. Okay, so the color red has a wavelength of 660 nanometers and a frequency of 454 terahertz. Okay, that's how you perceive the color red. All right, does anybody know anyone who's colorblind, or maybe you are colorblind in some extent? Okay, so it doesn't necessarily mean, it just means that you process light differently. All right, that your eyes process light in a different way. I have a friend, her husband can't tell the difference between blue and purple, which sometimes can be kind of funny. Okay, so like things don't match and whatnot. All right, and so we got to let him off the hook if he gets things wrong, because we have to remember he can't see different colors. Okay, so all I'm doing here is I'm looking for a connection, just like you did with the tables in example 1. You're looking for some kind of consistent pattern between the values, between your X values. All right, so I just want you to take a minute, and obviously we're adding and subtracting, so just do 660 minus 595 and see what the difference is. And then do the difference on the next one and see if you have a consistent pattern. And then do the same thing with your Y values or your frequencies. See if there's a consistent pattern there. If there is, it's linear. If there's not, then it's nonlinear. That's all we're doing here. Right, did you guys find a pattern with X? All right, what was my pattern? Plus 65. So for each of my X wavelengths, depending on the color, it increased by 65 nanometers. All right, what about my frequencies, though? I subtracted 50 on the first one. Then what happened? I increased by how much? 62. And then I increased by how much? How much was it? Did anybody do that math? 79. And then how much did I increase by? Okay, well, it doesn't really matter, does it? I can clearly see that this is nonlinear, not because of my X. Okay, so I'm going to say nonlinear because as X increased.
Wait, did X increase or decrease?
I'm sorry, decreased. All right, decreased by 65. Y, I'm just going to say changed because it decreased and increased. All right, changed by different amounts.
It just increased. It just increased.
No. Oh, I'm sorry. It did. 454 up to 504. All right, again, we're still saying something similar. It changed by different amounts, okay, or it increased by different amounts. All right, so definitely nonlinear. Any questions on this? Just how to tell the difference between linear and nonlinear. All right, so yeah, let's do some practice now. Let's get into big ideas and do some practice together.